easy because they go back to horizontal asymptotes, which were those first two problems on that worksheet. Okay? Seriously, this is really, really easy. What is the name of this function, 1 over x? Do y'all remember the name of it? It's a special kind of function. It is a rational function, but it's a special type of rational function. What? Close. Okay, here we go with charades. It starts with an R. Sounds like the Brindle. I don't know what you say. Reciprocal. Yes, you got it. Way to go. It's the reciprocal. I don't know. How do you write reciprocal without it sounding ugly? That's the reciprocal function. I didn't want to say anything that sounded ugly. That's the reciprocal function, which is a rational function. Okay? Do you remember which quadrants that the curve lies? First and third. Very good. Okay. Remember, it looks like this. And remember, it has to be close to the axis because if not, it has two asymptotes. What kind? Vertical and a horizontal asymptote. And you know that we designate the asymptotes with dotted lines or highlighter, whatever you so choose to use. But folks, look at the first one. Look at this piece right here, okay? The limit of the function, 1 over x, as x approaches 0 from the left. As it approaches 0 from the left. Where's the road that we're going to start driving? Right here, right? All right, where's it going? It's going down to negative infinity, right? Isn't it? I'm going to sing a song every day now. What about the next piece?
Positive infinity.
Where's the road?
To the right.
It's going to infinity. Isn't it? All right, now look. Nobody's, you know where I'm going with this. Where am I going? If I found the left-handed limit and I found the right-handed limit, what am I going to find next? The limit. The limit as x approaches 0 of 1 over x. If the left-handed limit goes to negative infinity, the right-handed limit goes to positive infinity. Will my fingers ever meet? No. This one is a D and E. It do not. It does not exist. And it does indeed not. It doesn't exist. It does, you know what I mean. Okay? A limit where f of x increases or decreases without bound as x approaches some number is an infinite limit. It doesn't exist. It's going to infinity. So infinity and D and E kind of, sort of go together. Okay? Kind of, sort of go together. You've got to know when to use negative infinity and positive infinity, especially when I don't give you a picture. Okay? It's not as bad as you think. Here's what you're going to look for. I need to add this slide in here. Okay? If x approaches some number, not infinity, not 0, it's approaching some number. If x approaches whatever that number is, makes the fraction 0 over 0, hey, what's that called? The indeterminate form. All part false. do this. If it makes the fraction some number over 0, what's that equal to? If it's undefined, then find the sign of the answer. That way, if you end up with a positive answer, your limit will equal positive infinity. If you end up with a negative answer, the limit will equal negative infinity. That's when we throw the numbers out the window and we really just focus on, is it a positive answer, is it a negative answer, okay? And I'll show you what that means here in just a second. And this is, seriously, this is not difficult. Don't make it difficult. If you can multiply positives and negatives together and divide them, you will be fine, okay? All right, we're ready? All right. Let's look at this function. We are not graphing doodly squat. We're going to use our noggin, okay? No calculator. This is telling me to find the limit. Let me back up. This is telling me to find which limit? How do you know? There's no superscript. There's no plus, no minus. All right, so I have to find the limit. In order for me to do that, though, algebraically, what do I have to find before I can find the limit? I've got to find the right-handed limit and the left-handed limit. And for whatever reason, I always start with the left because I think you need to. So let's find the left-handed limit. This is what we do. We go ahead and write it. 0 to the negative of 1 over x squared. Now, folks, we're approaching 0. Right? What's the easiest number to work with?
1.
All right, if we're approaching, though, from the left, what's going to be the easiest number to work with? Negative 1. If you wanted to work with negative 2 just to be on the safe side, then do it. Let's do it. I don't care. Let's choose negative 2. Just because. Doesn't matter if we do. Let's just say. If I plug negative 2 in for x, I really don't care what the value will be, but what will the sign of the answer be? It's going to be a positive divided by a positive, which is a positive. So that is going to approach positive infinity. Does that make sense? Yeah. All right, now, what's our next step? Right-handed limit. Now, if I chose because y'all know how I'm kind of crazy this way. I like to keep things the same. If I chose negative 2 for my left-handed limit, what do you think I'm going to choose for my right-handed limit? I'm probably going to choose positive 2. So let's choose positive 2 and substitute. I don't care about the value. I only care about the sign. 1, my numerator is going to be positive. What will my denominator be? Positive. A positive divided by a positive is a positive. Do my numbers match? So what is the limit as x approaches 0 of this function, whatever x squared? Positive infinity. They match. What if they didn't match? Then it would be what? D and E. It would be D and E. What do you think? Is that easy? Easy enough? Can we do another one? Let's do another one. I know, isn't this fun? It is fun. I don't care about the picture. I care about the signs of the numbers. You with me? Yep. Let's do another one. I got 3 minutes. It's approaching some number. And think about it. If I plug a 5 in here, what would be in the denominator? So I'd have 1 over 0, undefined. What's my next step? Think signs. I want left-handed limit, right-handed limit, the limit. Go. Do it. You don't need me to guide you through this. All right, so left-handed limit first, and you chose, we're approaching 5.
You can do 4 feet.
From the left, could I use 4? Could I use -1? Yeah, I could. Could I use 0?
Yeah.
Yes, I could. Because it's approaching 5. Well, what numbers are over here? 0, 1, 2, 3, 4. The negatives, right? Approaching over here would be 6, 7, 8, 9. Right? So I'm just going to choose. What do you think I'm going to choose?
0.
Why? Because it's easy. Because it's easy. It's easy. Very, very easy. See, close my mind and my mouth. Hey, what is a -5 raised to an odd power going to be? A negative. So I got a +1 over a negative, which is a right-handed limit. What'd you choose? So I just chose 6. Look at there. Didn't even know it. Positive over positive, which is a shut the front door. What the crap? What's the limit? The limit as x approaches 5. Now let me show you something. Bless you. D&E. What do craps look like? Crap. What's going to be at 5?
It's going to be no, it's going to be right here.
But what's going to be at 5? An asymptote. 1, 2, 3, 4, 5. What's happening to this function as I'm approaching 5 from the left? Where's it going? It's going down to negative infinity. That's way too high. What's happening over here to the right? It's going up. So what's happened? I see your eyes. Your eyeball. It's just getting worse. Look at that. Doesn't it have a vertical asymptote at x equals 5? So the limit is D&E. Okay? But we can find the left and the right-handed limits of these, right? Let's do one more. No, but I just want you to know that's going to be helpful to you in just a little bit. One more. Oh, it's as easy because it's already factored for you. Promise. Right, left. V. Hey, looking at that function already, will it have any asymptotes? Where? Okay, so see, you already know that it's going to have vertical asymptotes at x equals 3 and x equals -2, right? You should already know that. See what you get. left-handed limit. What'd you choose?
-3.
-3. If I choose -3, then that would give me a negative in the numerator, wouldn't it? That would give me another negative, which is a negative over a positive, which gives me a negative infinity. How many of you had that? For your left-handed limit, good. Okay, right-handed limit. What did you choose?
0.
Okay, 0's good. All right, so 0 plus 1 is a positive. Negative, positive, yes? Positive divided by negative is a?
Negative.
Ooh. What's the limit of this one?
Negative.
Did we do that right? 0 plus negative that. Negative, -3. Negative, negative. Yeah, so what's the limit? Negative infinity. Okay? So the limit adds, did you see the, I'm going to just put f of x. Okay?
It's not always that last. It was a funky graph. This we ended up having.
Okay. All right, we'll look at it. But I will check it. All right. 1 through 3, 18, 23, 25, 31, 37. I'm just telling you, if you don't show work for those odd ones, I'm not giving you credit. Don't even try it. Love you. Bye-bye. I'll be here until 4:30 today.